Yo, so just a quick update. The servos I bought, they did not turn out how I hoped they would. For some reason, like, they just wouldn't move when I got them out of the box, like, even when I tried rotating them. So I ordered new servos. I like one new servo from Amazon, which is right here. And this one works pretty well. Like in the fact that it can move and spin, but when I tried to hook it up with the Circuit Playground, there wasn't actually enough voltage being given to it, so it just made like a weird clicking noise. And so now to give enough voltage to it, I had to buy something from Amazon, which is going to be here like in a couple days. So I decided maybe don't leave everyone hanging, and just wanted to kind of show a quick update with how I am, where I'm at with CircuitPython. It's going to be a very quick video, I promise, just showing like the previous 5 projects and how I got them working on Circuit Playground. So let's get started. And yeah, different setup. Now I'm on the right side of your screen. It's kind of fun. So basically, this is Mu. This is where I write all of the CircuitPython code. And basically what I did was I just took all the 5 projects that we had previously and I just kind of did them here. So the first one was the light game. Basically, it's saying like if you're playing, set the index to RGB, so 255, which is just red. And then it says if index is 5, it checks to see if you're passed or not. And then a lot of the stuff is the same. It still checks to see if you press the button A, and then like at this part in time, and then it sees if like pause time is 0. So a lot of the same things. And then we also have the if point value is less than 10, less than 20, and then it just calls the red ring, orange ring, yellow, green rings, and those are defined very similarly here. And then this is just the color value. And I'll be going, when future projects, I'll be going more in depth for the code as well. Since you've already seen this is just kind of stuff that I wanted to go over. The second one is the accelerometer game, where it's the memory game. So here, show lights. Basically, this is just showing which quadrant you're in. So quadrant 0, 1, 2, and 3. And then Excel choice is basically saying like it returns the number for the acceleration. And this is how you access the acceleration. Just cpx.acceleration. And then based on the values, you return 3, 2, 1, or 0. And then here it's very simple. Just computer picks a random index, it shows lights, and then it clears. This is how you clear. And then it goes to sleep, and then computer turn ends. And then for the person turn, for every value in this set of values, they have to get the Excel choice right, and then it just keeps going. So a lot of the same framework. If we look at the thermometer one, this one was super easy to code in on like CircuitPython. This one, you just had to basically say if this is the CPX button is clicked, set singles to true, and then clear, and then basically make the temp equal a integer value of the temperature multiplied by 1.8 plus 32, basically converting from Celsius to Fahrenheit. And then if singles, do singles temp, else do tens temp. And this is really easy. Just get the number and then fill in the amount of pixels. And then if it's red, if it's over 50, just make sure you do red. If it's under, make sure you do blue. So super simple stuff right here as well. This one was really easy to code as well. One thing I forgot to touch on was the while true. And this basically just has it doing a forever loop, kind of like we saw with the make code. And here, cpx.pixels.brightness is equal to 10, is equal to 1. It just prints it from the console, and then it plays a .wav file, and it also makes like a kind of a white flash when the light value is less than 20. And I was able to get that through calibrating stuff with the console. So that's just something as well. And then the last one, this was the hardest one to do. This one needed a lot of importing and a lot of just finding stuff in the make code. It was really easy to just get the microphone data, but for here I guess that wasn't possible. So what I had to do was first create a mic value and then record that, and then basically what happened was it would record it and then give the magnitude of it using this function right here. And then basically the rest is the same though. While true, just make sure you get that time difference. If the time difference is less than 10, so between the start time and the stop time, just record the samples and say what the magnitude is and then print the magnitude. And if it's greater than 1,000, which was something that I found using the serial in the console, then you just add it to the array and then you fill all the pixels white. So that was just basically what I had done in the last kind of video as well. And then if you still need to showcase it for L in the range of length whatever -2, just make sure you fill in, you make it flash very bright and then clear it and then wait for a certain amount of time between the first one and the next one, and then that will be your difference right there. And then time.sleep, wait time. So then just go to sleep for that time and pause. So that's the code for all of the games that we had previously coded, and it's all right here. So CircuitPython and MakeCode can really work hand in hand, with MakeCode being very much of a structural kind of like way to first plan out, kind of like the I guess how would you say, like an outline for an essay. And then CircuitPython allows you to do a lot more stuff because it just gives you a lot more functions to play with. So that would be more like kind of just filling in the words of it and kind of going deeper with it. So yeah, that's just kind of how this code works, and I'll make sure to give you guys a quick demo as well. You'll see it's basically the same thing. It's just I just want to show you that it actually works. So yeah, let's just get started and get through these really fast. So this is the first one. This is the light game, and this one was a little bit more difficult to code on CircuitPython than on MakeCode. But here we go. Got it. All right. So let me just get this in play. So we got the red light. All right, one sec. I'll just show one demo real quick to show that it works. And I know that I'm covering it up, but hopefully I'm not covering it up in like the least intrusive way possible. All right, so there we go, 4. And then it just keeps going. It just does its thing. So next game is the accelerometer game. It's the memory game. I think it should be working now. So we got our memory game. We got orange and then purple. And I'll mess up like, oh wow. So there we go. I accidentally went here first and the game ends. So this is just a quick demo of the accelerometer and the acceleration game. All right, and now the third one, which is the thermometer. So I'm gonna upload that real quick. And then I'm getting it right now. All right, so we see that it is currently 83 degrees. So if I toggle between them, 8 and 3. Pretty cool, pretty sick. All right, and now we have the light lock that you basically put inside of a door plays, and it should give a sound and a light. So I'm gonna upload that one real quick as well. And I'll just use my hand, and you can see it made a sound and also turned the lights on. So pretty easy stuff. And then the last one is the clapback machine, so I'll just upload this one. All right, and for the clapback machine, One of the things here is that it is working on the second scale. So some of my claps might have been like on a 10th scale or even a 100th scale where it's like really fast, like very staccato. So to make this a little bit better in the future, what I would probably do is record the time in nanoseconds so it's a lot more precise. So yeah, this is just a video to give a quick update of what's going on and to show that I haven't just like totally left the grid. And I will see you all next week. So peace.